Hey, what's up? It's your old pal, Mr. Cook. We just got through identifying the conics and also putting them in standard form. So now let's just focus on graphing them. And graphing is really easy because the numbers that are in the parentheses after you put it in a standard form are all coordinates that are really helpful to graph this out. So like with a parabola, you don't have to go into like a ton of detail with it, honestly. Just graph like the vertex. So the vertex can be found for all of these. Always take the opposite of the numbers in the parentheses. Like for example, remember that you're making coordinates, so it's going to be an x value and a y value. The opposite of the number in the x parentheses is going to give you 3, right? So -3 turns into +3. The y value is going to be a -2. So that's the vertex of the parabola every time. That's how you find it. So go over 3, go down 2. And then after that, you just got to notice that, 8 is positive. So that means it's going to be facing upwards. Just like, draw an upwards graph like that. That's good enough for us. You can get more detail out of it, but really that's all you need to know. All right, 2. 2 is going to be, let's see here. So the x value is 4. And then the y value is -1. So that's my parabola. It starts there at 4, 2, 3, 4, -1. And then since this is a y squared, it's either going to open to the left or open to the right. And since the p-value is negative, it's going to open up to the left. So the graph's going to look like, something like this. I can fill in some of the coordinates at some point, but that's basically what's going to happen to it. Okay, and that's good enough for us. That's the graph. With a circle, the opposite of the numbers in the parentheses, that give you -2 for x and -3 for y. That gives you the center of the circle. So the left 2 and then down 3. And then if you take the square root of that number, it's going to give you the radius. So square root of 9 is 3, so radius is 3. So then from the center, just go to the right 3. So 1, 2, 3 would be like right there. And then to the left 3, 1, 2, 3. It's like right there-ish. Then go up 3, 1, 2, 3 would be like right there from the center. And then down 3, 1, 2, 3 from the center would be right there. And then just connect the dots. And it's like a circle-ish kind of thing. There you go. That's the graph. That's all I need. For number 4, the opposite of the numbers in the parentheses. So the x value would be a +4. The y value is a -1. And then the radius is going to be equal to the square root of 5. And that kind of sucks, but square root of 5 is like close to about like 2.5-ish or 2.3 or something like that. So we'll just have to round it kind of, okay? So it doesn't need to be perfect. Go over 4, then down 1, and then go over about 2.3. So go over 1, 2.3-ish to the left, about 2.3-ish to the right, about 2.3-ish up. So 1, 2.3-ish, like right there. Then go down about 2.3-ish. So down 1, down 2, down about 2.3, and then just draw your little circle out. And, that's good enough. Honestly, if you just like show this stuff and then kind of have a shape that's vaguely familiar and you make sure they graph the center, obviously, we'll be pretty happy with that. To draw an ellipse, again, just, find the center. So the opposite of the number with the x is going to be -1. The opposite of the number with the y is going to be 2. So if you graph that point out, here's how it looks. -1, +2 right there. And then here's what's interesting about an ellipse. I really like this actually. To find like an ellipse basically like has different radii, right? Like axially. So like in the x direction and the y direction, it'll have different radii. And when they're just like perpendicular to the x-axis, y-axis. But all you have to do is just take the square root of the number in the denominator. So 2 in this case, this tells you the x radius. Okay, so remember that x goes left and right, right? Like the x-axis goes left and right. So go to the left and the right by 2. So 1, 2, and then to the left 2 from the center, so over there. And then if you could, imagine if you take the square root of the y part, so 3, that's going to give you the radius in the y direction, up and down. So again, from the center, go up by 3, 1, 2, 3, go down by 3, 1, 2, 3, and then just connect all the dots on the outside. There's your ellipse. It kind of like looks like a stretched out circle in one direction, either the x direction or the y direction. So our last ellipse, again, just draw out the center. So that's going to be a +5 and a -3. So 1, 2, 3, 4, 5, and then down 3, 1, 2, 3. And then it looks like the x radius is going to be 5. So I'm going to go to the left 5, 1, 2, 3, 4, 5. And then to the right 5, 1, 2, 3, 4, 5. And then in the y direction, it's going to go up and down by 1. So up by 1 and down by 1. So it'll look something like that. It's a fairly eccentric ellipse, like little, I don't know, like squished or something. 7 for a hyperbola. Again, just draw the center. So let's see, it's going to be -2 and a +3. That's definitely going to factor into this. Basically, like you do all the same steps as an ellipse, and then you do a couple of like weird things after that. Okay, so draw out the center, -2, +3, right there. And then, in the x direction, your radius is going to be 3. So go to the right 3, 1, 2, 3. To the left 3, 1, 2, 3. And then it's going to go up and down by 2. So up 2 from the center, down 2 from the center. Now, here's the difference, though, okay? We are not going to draw we're not going to draw an ellipse. What we're going to do is draw a box. So draw like down from each of these vertices. Okay, so draw this little box. And then draw across the diagonals through the center, okay? So what this does is it creates these like asymptote lines that you're going to have for your hyperbola. All right, now, since the x part is squared, okay, since x part is squared and it's positive, okay, it's the hyperbola is going to open up to the left and the right. And actually, these little points that you drew right here, those are the vertices for, those little, you can call them, I guess, like parabolas going to the left and the right. And then they just follow the asymptote lines after that. So just like draw it like that. Just connect, the dot, and then just draw them along the asymptote. There you go. So there's our hyperbola. It's that easy. Similar to this one, draw the center. So that's going to be 3 for the x, -1 for the y. So let's see here. That's 1, 2, 3, and then down 1. And then, in the x direction, it's going to go by 5. So 1, 2, 3, 4, 5, like over there. And 1, 2, 3, 4, 5 over here. And then in the y direction, it's going to go up and down by 3. So 1, 2, 3. And then 1, 2, 3. And then draw the box around it. Draw your asymptote lines diagonally through the center. And then since the y part is the positive, that means that it's going to be a hyperbola that goes up and down. So those little points that we drew right here are the vertices, and then it just follows the asymptote lines. I should draw them a little more drawn out like that. There we go. It's a little better. Just follow the asymptote lines. And that's your hyperbola. Okay, so you can see after you have it in standard form, it's pretty easy. So yeah. All right, I'll end the video here for this one. I hope you found it helpful. If not, there are plenty of videos on how to graph conic sections. Again, use your friend YouTube and check it out. They're pretty easy. Okay, if you need some help, find your math teacher. You can always find me. I'm Mr. Cook. I'm available in the morning and after school, and I'm always willing to help. So come and get my help. I think that's it. Yeah, I'll see you in the next video. Bye-bye.